The St. Anthony Falls study looked at kind of some Twin City metro area lakes versus some that are non-urban, and they found that the chloride concentrations tended to be 25 times higher in the urban or the Twin City lakes versus the non-urban lakes, and sodium was also higher. And it did tend to be positively correlated with impervious surfaces. The more impervious surface we have, the higher the concentration of the chloride. Well, of course, this brings us back to, yes, road salt is likely the source of that problem. It's running off of our roads. Chloride is considered a conservative compound. It will stay in the water and travel with it, so it doesn't disappear. It was found that, basically about 3/4 of the chloride that's been applied for de-icing in the Twin Cities area is retained in our area lakes and groundwater. The rest, of course, some may be in the soils, but a lot of it then will travel to the Mississippi River and downstream. But we're still retaining a lot of that. So where is it going? It's accumulating in our lakes and in our groundwater, so that we're starting to see those higher concentrations.
Just explain the difference between chloride and sodium.
Well, sodium is usually the most commonly used de-icer is sodium chloride.
Yeah.
So when they dissociate, sodium is considered separately and can be more of a health issue or can be an issue in the soils and stuff too. But they're part of the same compound when it's a sodium chloride compound. But sodium is not really considered a problem in terms of aquatic life. I haven't heard of a criteria that's ever been exceeded for sodium. But in groundwater, it may be more of a concern.
So chloride is not salt?
Chloride is a component of the salt.
Okay. Is it like the same root word as chlorine or something like that? Is it?
Yeah, it's similar. So is it a problem when it enters our lakes? What is it doing besides potentially having some aquatic toxicity? So here we've got a diagram. This is from the St. Anthony Falls lab group. So if we've got a major road here and we've got snowmelt runoff, as I mentioned, when the chloride when it's dissolved in the water, it's a little bit heavier. It's higher density, it's going to sink to the bottom. So if we're monitoring up here, we're not going to see it nearly as much as if we're monitoring down in the bottom. So we get the salty water layer down in the bottom. So it forms that saltier layer in the bottom, less salty on the top. So the normal mixing process that we have in our lakes, usually our lakes are going to mix twice a year, in the spring and in the fall, and based on temperature gradients. Well, now we've got this artificial chemical gradient that occurs in our lake, so that we have this density now, this heavy saltier water. Now we're talking about minutely heavier. It's not going to be way huge difference in the density, but it's heavy enough that it's going to layer it, and you get this little layer here called the chemocline. Everybody's probably heard of the thermocline, where it's based on temperature. Well, we have kind of that same thing that kind of blocks the mixing. So our upper waters are going to mix, but not the bottom waters. And so this is sort of a hypothetical thing that we see might happen. And that means we're sort of changing the whole ecology of that lake. It's not going to be exchanging the nutrients and other oxygen and things that normally would turn over and exchange with that throughout that whole layer. Now we're just focusing on that upper layer. So is it really happening? And the answer is yes. This is Parker's Lake in Plymouth, where they did some monitoring, and I know this is kind of a busy slide, but this is turnover here where our temperature and our oxygen are the same, or in this case chloride, where it all equalizes. And this happened in the fall. Normally we have a spring turnover. There you can see that the temperature differs. So there's no mixing that occurs in the spring, and same as you go all the way through this next year. This is 2006 to 2007. We didn't get the turnover until the fall again. So it is happening. Now we're having a turnover once a year instead of twice a year. So that is going to kind of change the way that lake functions. So we're seeing that happen. there's other lakes that this has also been observed, or it's starting to happen in some of our other lakes too. We haven't really monitored a lot of our lakes for this yet, but it is a concern. Definitely a concern. So where is that chloride coming from? Now, when we look at rivers, wastewater treatment plants contribute a lot of chloride in the Twin Cities metro area. 96,000 tons. Road salt was found to be 163,000 tons. So it's a larger source, but our wastewater treatment plants are still a big source when it comes to rivers anyway. I don't think we really have any that are going much to lakes anymore, so it's not so much of a source for a lake. Of course, with our wastewater treatment plants, we use salt and we excrete salt, and we have water softeners that use a tremendous amount of salt. So that's where that's coming from, and that's a whole other issue we probably need to address in the future too. But road salt is obviously a huge source to our waters, whether it's groundwater, surface, or surface water, and definitely to our lakes. Some of the other sources, at least for the metro area, that were determined to be, a part of the whole picture, but insignificant in the metro area, are fertilizers, some industrial discharges, and natural sources. We don't really have a lot of high salt in our soils and area. So where specifically is it coming from? Well, we apply in the metro area about 350,000 tons per season of salt, of road salt. Now, statewide, that figures is going to be higher, but obviously in metro we do a whole lot more than greater Minnesota. And about 34% of it's coming from the cities, putting down on the city streets and areas, 24% from MnDOT on our state roads, about 21% from the counties, and the rest is the commercial package, so from our private contractors or some home use. So mainly for controlling roads is the majority of it, but we definitely have a lot that goes down on some of our other sources too, and we find sometimes some of the private ones tend to be at higher application rates than they would use on a road even. So if we look at one tandem load of salt, one of those orange trucks or whatever color they may be in your city or county, potentially that could contaminate about 8 million gallons of water. And how many of these loads of salt do we put out every year? A lot. Just we did some calculations. We work a lot with MnDOT and the Center for Transportation Studies, and we just did a few little calculations to kind of relate it back to things. And we determined that, or estimated, that just the salt applied by MnDOT alone from 1959 to 2008 could contaminate about 36 lakes the size of Lake Minnetonka, assuming it all stayed there. So we've definitely done a good job of putting it down and not really knowing that it was a problem for so many years. We do have some non-chloride options, non-chloride deicers, or some that are combinations, but they also have their own issues. There's none that is completely environmental friendly, despite what the bag may say. Don't believe it if it says it's environmentally friendly. They all have some sort of impact, environmental impact. So some of the ones that are non-chloride have fertilizers in them, potentially. Some have molasses in them or corn products. So they will use up oxygen as they break down, maybe produce some algae in your lake. There's also acetates, which have a chemical or a biological or chemical oxygen demand that it will also use up oxygen, really high oxygen demands. So none of them are perfect, and they have their limitations as far as how well they work too. What about sand? Sand doesn't seem like it should be very harmful, and if we could clean it all up, maybe it wouldn't be so bad. Of course, sand doesn't melt anything. It's just there for traction. It has real limited uses, but it's good for cold weather, for example. But we don't often do a great job of getting it cleaned up before it gets washed into our lakes and streams, where it can cover the bottom habitat where our aquatic invertebrates or benthic invertebrates live, and we need those as part of the whole food chain. Can carry pollutants into our waters as well, and fill in some of our shallow wetland areas and things like that. So sand also has its impacts.